And before I finish this video series, I now want to just give basically a huge crash course on continuous random variables. So as opposed to a discrete random variable which has a list of probabilities, a continuous random variable is defined by some density function, and that function is typically only defined on some interval. So in my example, I have f of x equals 6x minus 6x squared, and I'm only defining it on the interval x is between 0 and 1. And there are two things I can do. Firstly, I can check to make sure that I actually have a valid density function, so I need to check my two conditions. Namely, one, the density is never negative, which I've kind of illustrated here with my graph. And secondly, if I integrate this density over the domain where it's defined on, I will obtain something that's actually equal to 1, which if you follow my computations through here, you'll see that that's exactly the case. So then I know that my density function is actually valid. Once I know that, I can do some very classic computations. So for example, for the cumulative distribution function, i.e. big f of x, I am integrating from the lower boundary, which is 0, up to whatever value of x I'm interested in. And I'll be integrating my density, so that will be 6t minus 6t squared dt. And it turns out if you just follow through the computations, you'll actually get the same expression as I found above. And then for example, if I say I want to find a probability, like say the probability that x is less than or equal to a quarter, I can just plug that straight into my density function. And then I can also do some various other computations. For example, for the median, I'll be solving big f of x is equal to a half, which I won't do because that's too hard, but the idea is that this equation is what you're going to be considering. And of course, I don't need to look towards just the median. I can do, for example, the upper quartile, so I'll be solving big f of x equals 3/4. And then I can also consider the mode of the distribution, which is basically where any local maxima appear on the curve. And pretty much, I've illustrated with my graph that in here, it's basically just going to be at x is equal to a half. So pretty much, those are basically the only concepts there are to it. Of course, you can try doing it with other random variables, for example, the uniform random variable, but pretty much all of these computations can be adapted to pretty much every other problem, and that's all there is to it. Thanks everyone!